Hello, everyone. We are going live with lesson 28 today. Fix that echo. Sorry about that. Echo should be fixed now, so we'll wait for a moment for everyone to jump on. So we've finished our review of basic middle school geometry, and now we are working on a little bit of statistics today. All right, let me get these posted. Go ahead and start posting any questions you have in the comments of the behind the scenes video here, or you can post to Florida Math Live. That's the new spot where you can get the full experience on FloridaMathLive.com. And so I'm putting that link in the comments, and I'm going to put a link if you'd like to receive messenger alerts as a reminder for when we go live. Okay, I'll give everyone another minute to jump on and start posting your questions. Thank you very much for liking and sharing this with others that might benefit as well. I really appreciate it. Okay, so today we are looking at solving problems using scatter plots. So this is in the realm of statistics and probability. This is a very good area to study, I think, specifically when getting ready for the formidable FSA EOC exam at the end of Algebra 1. Unfortunately, about 2 and 3 students miss the cutoff score for the EOC at the end of Algebra 1 and are faced with taking it and retaking it until they pass, because it is a graduation requirement. And the subject of the statistics and probability, while it's a minor section of the test, there's a big opportunity because many teachers, because it is the last topic that's covered at the end of Algebra 1, many teachers don't get into covering it in the depth that needs to do it justice, because when EOCs start as early as April, depending on your school and district, for the end of course exam window, it's a bit frustrating where it's a final exam, but it's happening in April or first week of May. And of course, the 3 weeks before that, teachers are starting to prepare for the EOC by covering some of that end of course material. So a lot of times the statistics and probability material doesn't get covered as much as it should. And of course, how all these standardized tests work is often there's more weight given to problems that most people get wrong if you get it right, right? So if most people are getting the statistics problems wrong, then if you get them right, because you have an above average bit of knowledge of the statistics and probability section, then that's going to help your score. And the more people we can pass the first time through, the better. And that's the main goal of what we're looking to accomplish here. Okay, so we're at 7 o'clock. Looks like we have some people jumped on to the Florida Math Live section where you can post your comments. It has a really nice interface on the FloridaMathLive.com. It's fewer distractions than the main Facebook news feed. Just Just a little bit of a cleaner, more organized look there as well. All right, so solving problems using, we're in the wrong section, aren't we? That's what we did yesterday. Understanding two-way frequency tables, there we are. So this is the statistics section we're talking about. Sorry I had that on the wrong page for so long. All right, so let's go ahead and get the idea here. So Maria and David are using surveys to collect data about their classmates. Let's go ahead and compare these surveys. So she took a survey that has data such that the person's age, height, distance to school, number of brothers and sisters, number of pets, internet use per week, and can you see a pattern in what's happening here? What type of information is she collecting? These are all bits of information that can be measured with numbers, right? Let's look at David's survey. Gender, eye color, favorite animal, favorite color. Do you have a graphing calculator, yes or no? And do you have an after-school snack? Notice none of these can be represented numerically. They are all, as we're going to see in a minute, categories. So these are the two types of data, the two big of umbrellas of the types of data that you can collect. So the variables on Maria's survey are numerical variables, also called quantitative variables. And numerical variables are data that are measured as a series of numbers. The variables says how much or how many. Examples of numerical variable are height, weight, distance, speed, population, all things that could be measured with numbers. What about categorical variables? So the variables in David's survey over here are categorical variables. Any variable that is not numerical is categorical. These take on a value that is one of several possible categories. Sometimes the categories are words, for example, red, blue, yellow, green, different types of colors. There's categories also can be intervals of numbers, such as age groups of 1 to 5, the group of ages 6 to 10, 11 to 20. Maybe those are age groups for sports teams or something like that. All right, so first example, can we tell whether each of these variables is numerical or categorical? So there's age, volume, favorite movie, and type of weekend exercise. So which of these could be measured with numbers, and which of these would better fit into categories? And should be pretty straightforward to decide on that age is a numerical variable, so is volume in cubic feet is numerical. Favorite kind of movie, horror, comedy, action, those are categories, so that'd be a categorical variable, as well as weekend exercise, whether it's swimming, running, going to the gym, so those are categories of exercises. Okay? So over here, both of those happen to be numerical. Both of these over here happen to be categorical. So let's determine if the variables are numbers or words. So find the numerical values. That's really the description of how we identify, which we just did, what types of data we're looking at. So let's dig in a little further. So we have bivariate data involve two variables. So when there are two categorical variables, data can be organized in two-way tables. A two-way frequency table shows the frequency or count of each category. And in example 2, the variables are grade range and favorite sports. Oh, thank you very much for the thumbs up. I appreciate it. And so let's have a look here. So the relative frequency of elementary students who choose baseball as their favorite sport can be described as a ratio of 27 kids out of 57 total, or 27 over 57. And in words, that's 27 elementary students chose baseball as their favorite sport out of a total of 57 elementary students. Okay, so I'm going to leave this example, and with what we've covered so far, see if you can decide how this would work. So use the favorite sports table above to find the relationship, so the relative frequencies of the sport receiving the most votes by each grade range. Is there a relationship? What do you think? Let you think about that for just a minute. Okay, so use a favorite sports table to find the relative frequencies. So relative frequencies, I'm going to go ahead and draw a thicker border here so we can start to have a good idea of what we're looking at. So I'm doing a nice bold line to separate the totals a bit, okay? So when we're looking at each grade, we would say, how many students are in elementary school? That would be 57. Of those 57, 27 like baseball the best, 19 like basketball the best, and 11 like football the best. For a total, if you add those up, you're going to get 57. Looking at middle school, okay, oops. So looking at middle school, 22 like baseball the best, 8 like basketball the best, 24 like football the best when you surveyed the middle schoolers. Altogether, there's a total of 54 middle schoolers. Now one more time in high school. So when you asked the 89 high school students what their favorite sport was, 18 said baseball was their favorite sport. 23 said basketball was their favorite sport. And 48 said football was their favorite sport, for a total of 89 students. Now, when you look across, it adds up horizontally as well. So you would say, okay, well, I don't, of all of the students in all grades, how many liked baseball? So 27 elementary liked baseball the best, 22 middle school, 18 high school, for a total of 67 students. How many liked basketball the best, regardless of the grade? Well, a total of 50 liked basketball the best, and a total of 83 across all 3 schools or age ranges liked football the best. So we would say, how many students were interviewed total for this? So you can look at this 2 separate ways. So there's a total of 57 students in elementary school, a total of 54 students in middle school, a total of 89 students in high school. Add those up, you get the 200. You can also look at it the other way and say, okay, if we look at how many people like baseball, 67 like baseball the best, 50 chose basketball, and 83 chose football. So you can add that up this way and you get 200 as well. So let's look back at the question. So can we use the favorite sports table above to find the relative frequencies of the sport receiving the most votes in each grade range? Okay, so which sport received the most votes in each grade range? Is there a relationship? So we want to find, first we need to identify the sport receiving the most votes in each grade range, and then we're going to do something with it. So looking in elementary school, which was the most popular sport in elementary school? Baseball. The most popular sport in middle school? Football. And the most popular sport in high school? Football. Okay, so now we're going to look at, see if there's any significant importance or data that we can pull from this. So we want to find the relative frequency of that sport. So when we look at relative frequency, we're going to look at, because we're looking at by grade range, so I'll cover this up so we can ignore that for just a minute. So what I'm going to do is I'm actually going to look at that most popular sport and see if that was any type of a significance there. So 27 out of 57. Turn it into a decimal. Multiply by 100. Oops. Times 10 again. Okay, so 47.36. I'll go ahead and round to the nearest percent. So I'm going to actually say that 47% of the elementary school chose baseball. Now, is that extremely significant? Is that enough to say, hey, there's so many people in elementary school that like baseball, maybe we should just not even do basketball and football? Well, not necessarily. If this was 97%, then maybe we could say, yeah, maybe it's not worth having the other two programs because virtually everyone really just wants to play baseball. But what's a good cutoff? So maybe 50%, maybe half is the cutoff that we should use. So since it's less than 50% have chosen baseball as the most popular one, then we would say it's not a massively mismatched preference. How about this one? 24 was the biggest number for middle school. I said 27, I meant 24. 24, football over 54. So that would be 0.44 is 44%. So again, the most popular sport is football, but it's not necessarily a massive landslide. It's only 44%. So maybe let's see if maybe in high school we'll finally find a sport that is chosen by more than 50% of the students. And maybe that's how we would actually make a decision on who gets the new jerseys or the investment in the sport. Who knows what the reasoning is, but we're just looking at the data to see if there's any significance that we can pull from what's happening. So 48 was the most popular voted sport of football, got 48 votes out of a total of 89 high schoolers. So that would be 54%. Okay, so maybe that was the decision. Maybe it was if any sport in any of the grade ranges receives more than 50% of the vote, then maybe they receive extra funding or a new equipment or a new stadium. Maybe that would actually be decisions that could possibly be raised. So in all of these cases, If it was an even split, it would be 33, 33, 33, right? If it was evenly split between each sport. The only grade that showed a significant preference of having more than half of their students choose a single sport was the high school category, right? And when we're looking at high school, I know it's a lot of numbers that are scary, but we're just looking at that one column when we're only talking about high school, okay? Another thing, we can look at this and say, well, what about across the board? What is, maybe it was a sports, maybe it's ESPN starting to think about, what is the next generation going to be watching? What is going to be the new popular sport in 10 years that today's kids are interested in? So we could look at this and we could say, well, maybe in the elementary students now, so maybe we can start to think about putting more investment into baseball coverage in 15 years, because elementary is the one that shows baseball. Sorry about that. Basketball, they could actually make a decision that, hey, that's actually on the decline, perhaps, because in elementary, middle school, and high school, they that was not chosen as the most popular sport. But look at football. We can see, especially the two closest cohorts of students graduating, both chose football. So those ESPN executives might say, maybe we'll think about continuing to invest more in football, since that is the favorite sport of the kids that are growing up right now. So that'll be the biggest ad dollars in 5 or 10 years, that type of thing. So those are the things that we can actually start to make decisions about from data. So let's see, those are different analyses that you could come up with. Let's see what the book came up with for analysis of their survey. So they found that 47% elementary chose baseball, 44% of middle school chose football, 54% of high school students chose football. Most high school students prefer football over baseball or basketball, most being more than 50%. And this is not true for elementary and middle school. There's no preference over 50%. You could not say most students. That would not be an accurate statement to say. So even here it's close. So it would be inaccurate to say most students prefer baseball in elementary school, even though it's the most preferred. You could say it's maybe the most preferred, but it's not most students. Maybe you could say more students prefer baseball than basketball. But if you added up basketball and football together, you'd have 53%. So you're saying most students prefer baseball in elementary is not accurate lingo. Okay. I'll leave example 3 up for just a moment. See if there's any questions on the site. See if you can figure out example 3. I guess, yep, that's the question up top. Okay, so here we have a bivariate data table here. And it looks like it's broken down on one side for looking at male and female habits after school. And it's broken down into the three categories of playing sports, or playing video games, or doing homework. And I'm looking at the 8th grade students here, and that was asked in a survey of what they did after they got home from school. And the results are shown in this two-way frequency table. So the principal wants students to be more active after school. So of the students surveyed, what percent could be more active after school? What percent could be more active? So looking at this, we need to decide, so what is active and what is not? So let's break that down first. So playing sports would be active. Video games, not active. Homework, while a responsible decision, I would say, is not by definition being active, if that's the goal that we're trying to look at. So if I were to just break this down, so you can kind of make another label here if it helps you. So I would say like active and not active, right? So we kind of helped ourselves out by identifying, categorizing exactly what we're looking for. So, what percent of the students could be more active? So it's not a count of students, it's a percent of students. So here's what I'll do. Let me go ahead and get another piece of paper that I'll use to start to fill in the rest of this. If we did something like, I don't know if this is going to work or not. Kind of works. All right, so I just want to give us a little bit more room to work this out. So when you're talking about percentages, we actually need to look at the totals. So the total number of female students, show the work on the calculator here, is going to be 45 plus 12 plus 36. And that gives us 93. And I'll just do the totals all the way around just out of habit. We're not going to have to do all of them, perhaps. Maybe we will. Let's get the habits of finishing the totals here, okay? So we have 32, 37, and 24. Those are the males. Also 93, okay? Now we can look at the totals for homework. 60, as you can see, now 12 and 37. 49. And 45 and 32. 77. So what is the total? So what is the total of 77, 49, and 60? That gives us 186 over here if we were to add horizontally. What about if we added vertically to double check that we did that correctly? So as you can see, if we do it properly, adding this way after finding the horizontal totals, or adding horizontally after finding the vertical totals, we end up with the same total population. So what is that? That's all of the students total that were interviewed. Okay, so now let's not lose sight of the original question. We want to decide what percent could be more active. Well, that's going to be the addition of those two, right? Because we want to find the total as we continue down this way of that category, right? So the total of males and females in the categories of playing video games and doing homework. So you could have done it both ways. If you saw this from the beginning, you could have just added up these four numbers, 12, 37, 36, and 24. Or you could start to do it this way, is fine also. So what is the total of 49 and 60? $109. So 109 students could be more active. And that's what we're asking, is which ones could be more active. But now we have to be careful. Did it ask how many students could be more active, or did it say what percent could be more active? So it's asking what percent. This is a count. We're looking for a percent. So we want to actually do this. So when it's asking us for a frequency or percent, we do the observed number of what we're talking about divided by the total, right? So 109 boys and girls either play video games or homework. They could be doing something more active, like the ones playing sports. So I'm looking at this category of the count of students that could be more active, and we're going to divide that by the total students surveyed. Give us a decimal times 100. So that's going to be 58.6%. Did they ask to round off? So let's go ahead and round it off. So that would round to 59%. And that's how we would do that. So practicing this attention to detail is important. So first we had to look at the whole category and identify what is the active category and what's the non-active category. Then we had to find how many fit into that category that we were looking to identify. And finally, the question wasn't actually asking how many students could be more active, but what percent of students could be more active. So that's when we did the count of the category that we were talking about divided by the total number of students. And that is that. Let's have a look at example 4. Oops. Example 4. So I'm going to leave this up for a moment. Let me know if you have any questions. Actually, why don't you try this on your own, and then I will work on the answer together in just a minute. How did you do? Did you get an answer, for example, 4? Okay, so let's do 4 together. So Carl asked the students in his school what activity they like to do in gym class. The results are shown in the table below. Construct a two-way frequency table to display the data. Carl wants to recommend gym class separate by gender, and that students participate in different activities based on gender. Is there any merit to this proposal? So it sounds like he's maybe saying like, well, maybe he's implying that guys like to play basketball and girls don't, and girls like to play volleyball and guys don't like volleyball. So we should separate it to a guy's class and a girl's class. Maybe that's his thinking. So let's see if what he's saying is actually, if there's data to support his proposal. So he went around and he asked for numbers on each of like what everyone would vote for. Okay, so he asked all of the girls what their favorite sport was that they liked to practice, and also asked the guys the same thing to see if he could find some data to support his objective. So we need to actually find a frequency table or make one. So we need to take these counts and turn them into a number. So this would be 5, 10, 15, 23. 5, 10, 15, 20, 25, 32. 5, 10, 15, 16. 5, 10, 15, 18. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 26. 12, 21. Okay. So now in order to do a frequency table, we actually need to find the totals. So let's find the totals happening here. So for all of the females, so we're going to find how many total females were in this survey. 23 plus 32 plus 16 plus 18 gives us 89. And how many males were surveyed? And looks like I lost my feed there, didn't it? Why did that happen? What happened there? See if we can get the visual back on the document camera. Just a second, see if we can get that screen back here. In the meantime, see if you can figure out, if you wrote down the question at least, see if you can figure out the rest of that solution. Okay, looks like our Google Cam is giving us a bit of trouble here. I'm going to go ahead and call the end of this session. If you still have any questions I can answer verbally, we can do that. Unfortunately, it looks like we lost the video through the Google camera. So I will finish this example at the beginning of tomorrow's feed, again at 7 o'clock. Go ahead and submit your questions, what you thought about the material covered today. And I really appreciate you coming out and participating. I'll just try one more time, see if we can get it. Okay, we'll go ahead and call it at that today, guys. Thank you again for your questions, and let me know in the comments what comments, ideas you had, what you thought about the material today. I know it was a little bit new with the statistics. I can cover that a little bit tomorrow since today got cut short. But yeah, let me know how it goes, and I look forward to seeing you tomorrow. All right, thank you, everybody.